In this video, I'm going to be talking about the use of technology in measuring tectonic plate movement. So to conclude the plate tectonics chapter 6 of the Good Science textbook, there's a section which talks about the use of modern day technology in looking at how the Earth works, Earth's dynamics. So technology is used obviously nowadays, okay, rather than using analog means of measuring things, taking notes by hand, etc., etc. There's two forms of technology I want to talk about. First is GPS. Now, GPS is actually an acronym for Global Positioning System. GPS. And it involves a series of satellites orbiting the Earth. And there's around 31 satellites. The way it works is so here's the Earth. It involves some 31 satellites orbiting the Earth, okay, working together to locate your position anywhere on Earth. And so the way it works is this. So it's a very clever way of measuring plate movement. So suppose you've got a massive, let's go, a piece of land here. This thing here, which looks like a tripod, it's called a GPS transmitter. Okay, and it's basically anchored, its three legs are anchored into Earth's crust. Now, Earth's crust, as we know, is made of tectonic plates, and these plates are always moving. Okay, they're very dynamic, but they move very slowly. I should mention, like a few centimeters every year. And GPS can actually help us keep track of how these plates are moving. So here's how it works in a nutshell. So the GPS transmitter talks to satellites up in space. So it sends a signal. And these satellites help the transmitter figure out exactly where it is on Earth's surface. And I should note here that there's multiple GPS transmitters on a plate. These can be separated by many kilometers. And over time, the GPS transmitter keeps checking its position and it notices any changes. And if the transmitter moves a bit, just slightly, it means that the tectonic plate's also moving. Okay, and by collecting this information from many transmitters across the Earth on different plates, scientists can then see how the plates are shifting and sliding around. So that's one form of technology used to measure plate movement. Another form of technology is sonar. Now, sonar is actually an acronym. It's also an acronym. It stands for Sound, Navigation, and Ranging. It's basically the use of sound waves to measure plate movement. So the military uses this a lot in submarines, okay, for detection of objects underwater. But it's also used in studying the Earth's structure. Suppose you've got a boat, okay, some water, underwater formation on the ocean floor, let's say. So the boat has a receiver, transmitter and a receiver. Okay, so it transmits a sound pulse, hits the ocean floor, and that reflects back to that's the reflected sound wave. That's the transmitted sound wave. And it's really just simple maths. So the machine, the computer uses a very simple mathematical formula. V equals D divided by T. We know what the speed of sound is in water. That's around 1,500 meters per second. We know how long it takes for the pulse to travel from the transmitter to the receiver and calculate that. We can rearrange this formula to work out the distance, okay, the depth of the water. It's just velocity times time. And this was how underwater mountains were discovered back in the mid-20th century, or around the mid-20th century. And when it comes to tectonic plates, these massive slabs of Earth's crust that move very slowly over time. As the plates move, they can create underwater mountains, as I've mentioned before, valleys and even earthquakes. And so sonar helps us see these underwater features and can track how they change over time. So two very useful forms of technology used to measure tectonic plate movement.